When Austrian physicist Wolfgang Pauli proposed the existence of the neutrino in 1930, he apologized to his fellow physicists for proposing a particle that could never be observed. In fact, something like 100 trillion neutrinos are passing through your body every second. And they can pass through an entire light year's worth of lead with only a 50-50 chance of bumping into anything. At the time, the proton and the electron were the only known particles, and something weird was going on with a form of radioactivity called beta decay. During beta decay, one atomic element changes to another atomic element and releases energy in the form of an electron. It sounds pretty straightforward, and if that was all that was going on, it would be pretty predictable. The electron that appeared during beta decay would appear with the same energy, the same speed, and be heading off in the same direction. But that's not what they found. Sometimes the electron had a bunch of energy, sometimes it didn't have very much energy, or anywhere in between. Some really good physicists at the time, including this guy, thought that maybe energy in nuclear reactions isn't conserved, maybe it's statistical. But Wolfgang proposed a new particle and called it a neutron. But 2 years later, an English physicist discovered a much more massive particle and called it the neutron. The name neutrino was jokingly coined in a conversation between Italian physicists Edoardo Almaldi and Enrico Fermi, and it means little neutral one in Italian. And in 1934, Fermi did what he did best, crunching some numbers and coming up with a theoretical framework to actually detect and explain neutrinos. And that's a really hard thing to do. They don't interact with things like regular particles. The magnetic and electrical forces have no effect on them. They really only interact with a force called the weak force, which, as the name implies, isn't very powerful. But shitloads of nuclear reactions are going on all the time in the nuclear furnace, which is the sun. Hydrogen in the sun gets turned into helium at about 10 to the 38 power times every second. That's a 10 with 38 zeros every second. And every time that happens, a neutrino gets born and starts flying. Photons emitted from the solar core may take 40,000 years to get to the outer layers. But neutrinos pass right on through the sun at nearly the speed of light, taking mere seconds to escape. And then it takes less than 9 minutes to get to Earth, passing right on through Earth too. They were first actually discovered in 1956 using nuclear reactors by a team of physicists including Frederick Rains, who won a Nobel Prize for it about 40 years later. Nowadays there's a handful of ways to detect neutrinos, and I'll talk about some neutrino detectors tomorrow.